Today we have two guests on our Future of Medicine series, Ali Yedison and Michael Snyder.
We actually have early alerting system for infectious disease from a simple smartwatch, but they're not yet incorporated in their health system, and they should be.
Michael Snyder is a precision medicine pioneer who's gathering trillion-fold more health data than typical doctors, with 17 healthcare companies and 900 published papers proving he's revolutionizing how we monitor human health.
You can start to pick up things like early signs of Alzheimer's, dementia, cardiovascular disease, all from an image of your eye.
And Ali Yedison is the Imperial College London professor creating color-changing biosensor tattoos that monitor your health, whose breakthrough innovations have earned global recognition from CNN to BBC.
These tattoos can change their color, or they can change their color intensity in response to a wide range of target markers. So what we are trying to do here is to develop technologies that can be utilized for early detection of some of these disorders and diseases. We can have invisible tattoo inks. Only your smartwatch or your smartphone will be able to see.
One of the phrases that I'm hearing batted around increasingly in the space these days is this thing called Omics. Take me into what this is in layman's terms so we can really understand this.
Sure, yeah. Om really refers to a collection of things. So your genome is your collection of genes, basically your DNA. Your transcriptome is a collection of your RNA. You may know that genes make RNA, makes proteins, which in turn wind up leading to metabolites. And each of those collections becomes an ohm. So as I say, your transcriptome is your collection of transcripts, your proteome is your collection of proteins, your metabolome, collection of metabolites, and then all of them together are called omics. The bottom line is it's really a collection of as many molecules as you can measure. And that's actually what we do. We do very, very deep measurements out of people's blood and urine to get a much better picture of their profile, their health profile.
Yeah, so basically, if I understand then broadly, it's a way to look at a wide range of molecules in the body that really matter to our health, and then find ways to quantify them, to measure them. And is the intent of this then to get a better grasp on what's happening inside the body sooner so that we can understand what's going well, what's not going well, and then figure out what to do about it? Absolutely.
So what happens when you go to a physician's office today? They'll measure maybe 15 things. And we're capable of measuring much, much more, tens of thousands of molecules. And from that, those deeper measurements, we think we get a much better picture of people's health. So if you think of your health as a 1,000-piece jigsaw puzzle, with omics, we're trying to cover 700 or 800 of these, I would say. Whereas in a physician's office, I would argue you're collecting, 5 or 6. We just get a much, much better picture of people's health. And so we started a project a number of years ago, profiling people just this way, collecting very, very deep data on them from their blood, from their urine, even their poop. Your so-called microbiome has a lot of information in it. And from that, detailed profiles, we actually got a better picture of people's health. And in fact, in the first 3.5 years of the 109 people we were following, 49 learned something pretty important about their health. And some was a big deal, like we call early cancer, 2 people with serious heart issues, pre-cancers, all kinds of different things. So we think these deep profiles really give you insights. I should point out these are all found pre-symptomatically. So the folks didn't even have symptoms yet we could see something was off. And then they did follow-ups and these things were caught. And in virtually all cases, then they came out healthy as a consequence. We didn't wait for them till something really became catastrophic. And that's how medicine's practiced today. This is what we're trying to transform. Today, most people go to a doctor when they're ill. I call it sick care. We're trying to do true health care.
Yeah. If this is so effective, why aren't we doing this on a larger scale?
Part of it's because who pays? Nobody pays to keep you healthy, at least in the U.S. especially. We, again, this incentives are totally misaligned. People usually go to the doctor when they're ill, and then they get paid for that. Who's going to pay to get your genome sequenced now because we don't know if what we do know is that if you do sequence your genome, there's a chance we'll see what you're at risk for, like BRCA mutations, if you've heard of those, put women at high risk for breast and ovarian cancer. That's useful information to know, but unless they already know you're at risk for it, you won't get that test. So nobody pays for these things while you're healthy. That's the problem. So we really need to change financial incentives. And I would argue the wearables, these came out as fitness trackers maybe a dozen years ago. We actually started putting them on people realizing they're pretty powerful health trackers. And it's pretty clear that, for example, now we can show when you're getting ill from an infectious disease, say COVID, your heart rate goes up ahead of time. We can pick that up. And so we actually have early alerting system for infectious disease from a simple smartwatch. And it turns out these pick up other things as well, AFib and things like that, mostly discovered anecdotally. But they're not yet incorporated in their health system, and they should be. And here's a good reason why. If you go get your heart rate measured in a physician's office, it's almost always elevated for most people. It's called white coat syndrome. So they get nervous, their heart rate goes up. So the measurement's not terribly accurate. But if I pull a heart rate measurement off you first thing in the morning, it's a pretty good measure of your true heart rate and what your actual health state is. And heart rate, by the way, and heart rate variability, these are two parameters that are very, very powerful for monitoring health. And we think they should be incorporated, and you should get them right off your smartwatch. I think we should be giving every person a smartwatch to be tracking their health and just to be part of their enrollment plan.
Yeah, I mean, it is fascinating. When we go to a doctor, as you described, we pretty much only go when there's something, quote, wrong, and observably, or when you actually can feel something is wrong. It's like, okay, so now it's time to actually do the thing. And then we get a measurement taken, some sort of diagnostic measurement, blood test, whatever it may be. And it's a snapshot in time, right? Which is valuable for that moment in time. But then we're ignoring, what about, like the 23 hours and 45 minutes outside of that moment in time? And like you just described, often the simple experience of being at the visit changes our physiology in a way that may affect the measurements.
Yeah, so I'm a big believer we've got to be measuring people while they're healthy and catch, any problems early, pre-symptomatically, because then it's easy to fix people. If you wait till the symptoms arrives, cancer is a good example. Once cancer is metastasized, moved to other sites in the body, it's very hard to cure. But in contrast, if you catch cancer early stage, you can almost always manage it quite effectively. So we really need to go to true health monitoring and not sick care treatment. And so that's a good example. And I think on the wearables, they're just so great because they measure you continuously, 24/7. And so they're always tracking your health. An analogy I like to use, we all drive cars with dashboards. The dashboards are talking about a car's health. Race cars have over 400 sensors on them, and they relay the information to the dashboard so you can see what's going on. Here we are, as people, we don't have any dashboard for our health. It's more like a sick dashboard, and we could be tracking this stuff all the time and catching conditions, at least getting a sense if things are off, and then you go in and get a proper follow-up to actually see what is off.
That's such an interesting analogy, right? Because if you think about your car, like nobody would imagine getting in their car or buying a car without any indicators, any dashboard, like even the most basic, like, do you have gas left in your tank? Is your battery okay? Is your engine overheating? Do you have oil? Like, we wouldn't imagine driving a car without some sort of fundamental indicators that are always on and active when we're in it. And yet we're kind of doing the exact same thing with our lives and our bodies.
Isn't that crazy? It's nuts, because we really should be tracking our health. And it's very easy, right? If you wear these rings, and you may know I have a lot of these devices here, my 4 watches, my rings, even my hearing aids, I do wear them for hearing, but they're sensors as well, and they're powerful, right? They'll detect when people fall these days. That's almost standard, in fact, for most hearing aids, but which I don't need it for that, but I like the fact I use it for hearing, but I do like the fact it measures other things. And I think ultimately we can just incorporate these into leading better lifestyles. And I think one of the best set of devices out there are these continuous glucose monitors. I don't know if you've heard of them.
Of course.
They measure your glucose every 5 minutes. those are like totally life changing, because it turns out that a lot of so-called normal people and people who are pre-diabetics, they actually still have glucose dysregulation. As you get older, this goes up, by the way. And so it turns out that glucose, if you get these spikes after you eat a meal of glucose, and it's been correlated that these spikes are actually associated with cardiovascular disease and such, if they're too high and too many of them. But now you can measure that just by these simple monitors that you can get in a drugstore. And you put these on and you'll see what foods spike you. And it turns out it's very, very personal. That some people spike to potatoes, others to pasta, some to white bread, some to brown bread. We're all different. And it's not 100% clear what that's due to. Some of it's due to our microbiome, but it's other things we do, other factors, undoubtedly. And the nice thing is, if you know what spikes you and what doesn't spike you, we'll eat the things that don't spike your glucose and avoid those that do. And now with AI machine learning, you can actually make predictions quite accurately to say, all right, well, if this food spikes you, avoid these other foods too, because they're very related. And these other foods that don't spike you, eat those kinds of foods. And we can tell you very explicitly what to do. And you can even take this one step further. If you are going to eat something that spikes your glucose, do a 15-minute brisk walk. That'll suppress your spikes. So there are things you can do to adjust your lifestyle so that we can all lead, happier lives.
Yeah, and I mean, I think this is really important also, especially let's take the case of continuous glucose monitors. These are these little things where you pop them on generally most people wear them on the back of their arm. It's painless. It's, they keep going and reporting in every 5 minutes or so for a couple of weeks often. And, I think one of the big wake ups with this, and I've experimented with a number of them. In fact, there was a time where I was wearing 2 different brands in the same spot on different arms because I kind of wanted to compare how they were each reporting. And interestingly enough, they were reporting different numbers. And I thought that was fascinating. And then, because I'm a little bit nerdy, I also was measuring blood glucose using an actual blood meter and poking my finger. And that gave me yet a third reading. So talk to me a little bit about the accuracy of these devices.
Sure. Well, first of all, the ones that you wear on your arm, these patches, if you will, they're measuring what's called interstitial glucose. So that's the glucose, essentially in your tissue, whereas the blood glucose is in your bloodstream. So there actually is a 5-minute lag. It varies a little bit from person to person. So they should be shifted a little bit. Whereas the blood glucose rises pretty quicker. The interstitial is a little bit delayed. You're right that the devices themselves are off a bit, and it's usually about 10%, could be as bad as 20%. It's not so much more than that, but the things that you're really looking out for are these giant spikes anyway that, are essentially, they're not 20% spikes. They're more like factors of 3 or 4, 300% spikes that you're watching out for. So people's, if you have perfect glucose control, you're around, say, 85 or 90 is the number that people use. But it's very easy. Like, it turns out I'm a type 2 diabetic. I'm an unusual one. We can talk about that. But your glucose, like in my case, if I eat the wrong food, it'll spike to 380, even more. So it just goes totally nuts. And those are the things you're looking out for. You're trying to look for things that take you, it's called out of range. If you're healthy, you want your glucose to be under 140. If you eat a grape, it's like eating sugar. That'll spike you maybe temporarily out of that. But if you don't have good glucose control and you eat a potato or rice especially, you'll see it can go up and stay quite out of range for some time. And that there's a formula that actually translates into a more standardized measure of glucose levels. It's called hemoglobin A1C. That it's modified your hemoglobin of all things, and that is the standard measure most people use today. Although ironically, the better measure is this glucose monitor, believe it or not. That's a much better measure of your glucose dysregulation. And so my prediction is down the road, that'll become the gold standard, even if they are shifted off by 20% or what have you.
Yeah.
But the most important thing about these things is, and we've shown this, so I have a company called January Eye. We showed just by wearing a monitor for 10 days, people improve their what's called time in range, getting their glucose better under control. They're very visual. When you see what spikes your glucose out of control, you eat differently. One of my favorite stories is a reporter was talking to me. He said, I thought I was eating the healthiest lunch. I had salmon on salad every day for lunch. What could be better than that? So then he puts a glucose monitor on and his glucose just goes totally out of range. And you can guess what it was. It was he put a dressing on a salmon that had sugar in it. And it's an easy fix, right? Once you realize that, well, you leave the dressing off. And sure, maybe it's not going to taste as sweet. Probably tastes better, actually. You don't mind leaving out sugar once you start leaving it out. Like I cut out sugars years ago, and now I find it distasteful if there's too much sugar in anything. So anyway, he basically left that out, and he got the healthy lunch he wanted. So
yeah. And it's like the real-time feedback is really powerful. And I remember this back from like many years ago, and I remember hearing basic data on when somebody would start to work with a nutritionist. And very often the opening move is, okay, so they send them home and say, keep a 7-day food journal. And without any other guidance at all, the simple act of then tracking what was going into their body, by the third day, they were completely modifying what they're eating simply because of the first time they're saying like, wait, what? This is what I'm actually putting inside of me. And once you realize
muffins are not very good for you. Yeah, so
right.
Absolutely. Yeah.
So when you have something that's actually automatically looking inside your body and reporting what you can't easily see from the outside and showing what's happening inside of you when you behave in certain ways or consume certain things, I know for me, it's been incredibly powerful. I'm curious also, and I'm guessing you would say this is one of the benefits of these wearable devices, CGM in particular. There are foods where, people would say, or, professionals would say, these are good for you. These shouldn't affect your blood glucose all that much. I would eat them and I would see a spike. So this is much more individualized than maybe we're led to believe, isn't it?
It sure is. And also the way things are labeled can be very misleading. Have you seen things called protein bars,
right?
Kind bars? Some of them are just totally loaded with sugar in spite of the name. So this kind of tips you off. Now, in principle, you could probably read a fair amount of it from the package. Although, as you point out, it's very personal. So there's no better way to know what's going on than seeing it. You eat the thing and you see what it does to your glucose, and it's very, very behavioral modifying. As they say, it's incredible. Everybody wears one of these, changes their eating habits.
Yeah.
And in a good way.
Yeah, absolutely. I mean, it was interesting for me because I did an experiment where I had a sweet potato, which in theory was supposed to be better for me, more fiber. It's a different thing. And then a white potato to see for me, there was actually zero difference. They created an almost identical spike. I was like, oh, there's something about my body that's reacting almost exactly the same to these two different things, even though one is supposedly designed to create a lower spike, to have a lower glycemic index. So it's interesting to see the individuality.
Yeah. I have a good one for you. Some people will spike more to white rice than ice cream. So yeah, it's very personal.
Yeah. Let's talk about smartwatches also, because you started out by talking about them. As you raised your arms in the image, you wear 6, 7, 8 different devices on your wrist?
No, just 4. Let's see if I can get them all on the screen there. And my ring is another one. Yeah.
Right.
And my hearing aids is yet another sensor. So yeah.
So take me a little bit deeper into smartwatches and what they're allowing us to see now that is really helpful.
Oh, they're super powerful. So they'll measure resting heart rate variability pretty accurately for most devices, actually. They may not be as accurate when you run really hard and your heart rate goes up, but we often don't use that as much in routine, health monitoring. But they'll also measure your blood oxygen, some accurately, some not so accurately. Skin temperature is another thing they measure. There's something called galvanic stress response, which is conductance on your skin. That actually is not usually used in a doctor's office, but it turns out it has medical value. So meaning when you're diabetic, your skin gets drier and you actually have less conductance, and you can pick that up. And likewise, when you're stressed, you'll sweat more and your conductance goes up. So there's a measure for stress that you would otherwise necessarily get from a doctor's office. What else do they measure? With not continuously, but usually when you put your finger on it, you can measure your, EKG, your heart patterns, if you will. And some of the devices will measure blood pressure. Some of them are accurate, some are not. Now, even when these measurements aren't accurate, like skin temperature, some devices are quite good, some not so good. But even if they're not accurate, they'll measure the shift, the change from baseline. And that's what's most important, knowing your healthy baseline and seeing when things shift away from that. That's so key.
So, like, for example, when you said earlier in our conversation that you were able to detect the early onset of a virus in somebody, maybe before they even were experiencing symptoms, what were you looking at? What did the devices tell you that let you see this?
Yeah, well, backing up a minute, the reason we got into this, we started putting these on the folks we're following, these smartwatches, and including me. And early on, I discovered when I first got Lyme disease, because my blood oxygen dropped. There, I had a blood oxygen monitor because they weren't on the watches back then. Now they are. And I saw my heart rate go up. Those two parameters changed. I later saw my skin temperature shift. So that was from Lyme disease. Again, it was a very clear signal. All pre-symptomatically, by the way. So I had not yet had symptoms, yet I saw these shifts. And so that's what got us into the space, picking up Lyme disease. And then we went on to discover that you can tell respiratory viral infections, including asymptomatic ones from that. And then we actually published this in 2017, and then COVID came. As you might imagine, we ramped it up big time. And the number one parameter we were following at the time is resting heart rate. It's very sensitive measure. As little as 2 beats per minute, we'll pick that shift. And that can be a respiratory viral infection. It can be other things triggering it as well, including, by the way, workplace stress will increase your heart rate. So I think these devices, they're very powerful for physical stresses like respiratory viral infection, but they're also going to be powerful for mental health markers as well, which we do not have good markers for. So I think this is going to be very, very important in the future for all kinds of measurements. So these, back then it was resting heart rate. These days, it's probably not appreciated. Heart rate variability, which is, so your heart rate has a pattern. You hear, oh, I have 61 beats per minute or something like that as my resting heart rate. Well, it turns out your autonomic nervous system is always firing it, and actually there's slight shifts in that. And a highly variable heart rate is good. Believe it or not, if your heart rate is not variable, then that's actually bad. It's a sign of disease. And so when you get an infection, when you have cardiovascular disease, even cancer, your heart rate variability drops. And so your watches can actually pick that up for cardiovascular disease and for respiratory viral infections, and we think for some other things as well. So again, they're tracking some pretty important health parameters. And the other thing they do is they do modify people's behavior as well. So I'm a believer that everybody should get a smartwatch when they first enroll in a health plan, because you will actually improve your data. Now, most people learn their patterns, throw the watch in a drawer after 3 months. But if we could actually incorporate this into their healthcare, hopefully they would wear it all the time. And one example I like to give is that a lot of people, they've trained themselves to walk these 10,000 steps a day, and everybody who gets the 9,500 will walk that extra 500 just to get that 10,000 milestone, if you know what I mean. So I think they also give some behavioral, improvements just by wearing these devices.
Yeah, I completely agree. I know that's been the case for me as well. What's the future of these types of devices? If you're looking ahead, say 5 years now, and you're looking at the evolution, what do you see either in development or coming that would be the next evolution of these? That would be just the next also order of magnitude of being helpful and giving us really good information.
Yeah, well, we certainly need to adjust our healthcare system, become true healthcare, not sick care. And I think as a consequence of that, if we can incentivize people when they sign up, you get a $10 a year, even just something trivial, maybe $50 a year discount if you wear your smartwatch or wear a CGM once a year. I think that would then make these things commonplace. So I would love to see that. What other kinds of technologies are coming? Well, retinal scanning is turning out to be very, very interesting. either, and I think that can be done very, very quickly, either, more sophisticated device, say, right outside of your grocery store or maybe at work, or even from your smartphone. And these days, you can certainly pick up a lot of eye conditions from a retinal scan, but you can start to pick up things like early signs of Alzheimer's, dementia, cardiovascular disease, all from an image of your eye. And I think we're going to see that accelerate in 5-10 years from now. That could become a routine part of your medical exam. Again, it's another window into your health. And I predict there'll be other things as well. Facial recognition, voice recognition that are also health monitors. I think the combination of all these things is going to be super, super powerful. Again, for passively tracking people's health, make it low energy so it's very easy for them to do this. Another area that our lab pushes on is remote monitoring, where you do little droplets of blood. You can collect them on a device. We actually spent 7 years perfecting this. I know what this is going to sound like, but ours actually does work. You give these little drops of blood, you mail it in to our lab, and we can now measure 7,000 analytes off this drop of blood, 7,000 molecules, if you will. Very, very powerful. And we've commercialized this with this company, Iolo, that actually can measure 650 metabolites, again, from one of these mail-in drops of blood. And they read out all these 20 different categories: oxidative stress, inflammation, heart health, kidney health. They're measuring all these metabolites, again, that are windows into what your biochemistry looks like. That's very, very powerful. And again, part of this whole thing will be using AI to actually take the data around you, plus all the data that's out there. Medicine is data now, and you actually incorporate that and make very personalized recommendations about this. And it's not just exercise more, eat better. It's really, eat this. And we talked about this with glucose monitoring, about how it really tells you what to eat, not to eat. But if you're up for oxidative stress, there's things you should be eating that will probably help mitigate that, and other things as well. So I think we can use information in a way that's never been possible before to help us live long, healthy lives. And that's really the goal. I might just add one other fact, which is, you probably know that, at least in the US and Europe, there's a big difference between people's health span, the amount of time they live healthy, and lifespan. And it depends how you measure that, but it's basically 11 to 15 years, people would say, meaning the last decade of life people live is unhealthy. And we want to change that. We really should have people living long, healthy lives and, then pass away. And not only would that be more fulfilling, but I think it would save a ton of money. And so I think by health tracking, we can achieve that goal. At least that's what I hope. And probably at the same time, you'll extend people's lifespan a little bit too.
Is there a risk of, what's the right language here? Not over tracking, but when we start to quantify everything that's basically happening within us, and we have devices that report it in real time, is there a risk of actually being able to give ourselves so much real-time information and feedback that it kind of sets us into a neurotic spin that actually becomes unhealthy?
Yeah, that might be true for some people. I predict that's not going to be true for most. I think you have to educate people. I have to, when people first wear their watch, they start they're very attentive. But I think you learn how to work with that information in a positive fashion. So I think it can actually help allay some of your concerns. Like, people are at risk for certain cancer. If they get whole body MRIs, they can see whether some of the stuff is there or not. It reminds me a little bit when genome sequencing first appeared, people getting their genomes, their DNA sequence, and then predicting risk. Physicians were very much against that. Most were, not all. Most were, and they were worried we were going to turn everybody into hypochondriacs. It's going to cost millions of dollars. Well, they've warmed up to this idea now, most have, because imagine you have a BRCA mutation. Well, then you go get screened more often. You can use this information in a positive way, and I think that's how we have to approach it. We have to educate people that way, both physicians and patients, that yes, this may expose things. You should assume you're at risk for something. We all are. And so you want to know what those somethings are, again, so that you can better manage your lifestyle, know what to get checked up on. We don't even know how often you should get measured, right, for your health. That's not really clear. And I would argue it depends what you're at risk for. If you are at risk for diabetes or something, well, then you get that measured a lot more often. If you're at risk for breast cancer, make sure you're getting your mammograms, this sort of thing. So I think we could just incorporate this into what we normally do, much back to the car. If you see things going off, well, then go get it checked up. And you don't wait till your car breaks down to get things fixed, or you shouldn't. It would not be the best way to operate.
Yeah, feels like a good place for us to wrap up. Thanks for giving me a couple extra minutes there also. I got to talk to you for hours more, but I know you got a bogey. So super useful. I'm excited to share all this with our community.
Great. That was my pleasure.
I think maybe a good place for us to start out, if you could maybe just provide a bit of general background more broadly about the research that your lab is focusing on now.
Yeah. So my background is in engineering, and my lab is based in Imperial College London in the Department of Chemical Engineering. And we work on a number of medical devices, biosensors, and other types of key wearable and implantable platforms for medical applications.
What led you into this?
Primarily my curiosity and having a propensity to do something good for the world.
Tell me more about biosensing technologies. Walk me through what you're talking about here in sort of like layman's terms.
Biosensors are crucial technologies, and they are usually a part of a medical device that allows us to measure the concentrations of a target biomarker. So this target biomarker can be glucose, it can be protein, it can be hormones, it can be cortisol, for example, a stress hormone, or other types of key important markers that allows us to determine the health condition of an individual. So such devices can come in different forms. They can be, for example, electronic, they can be optical, or they can be magnetic. And they're usually integrated within a medical device that allows us to track these biomarkers usually in real time.
So if somebody's hearing this, my sense is if they have experienced this, it may be like the easiest sort of like thing that they might envision is some sort of wearable device, or even for those who have been curious about glucose monitoring. I think millions of people now are familiar with the concept of a continuous glucose monitor, that little round thing that often you see on people's arms. Are those examples of what you're talking about here?
Yeah, that's exactly right. So we are talking about glucose monitoring systems and continuous glucose monitoring platforms, actually a relatively new technology that has emerged about 15 to 20 years ago. And they are currently the market leader for applications in type 1 diabetes monitoring. But these devices can also be used in point-of-care settings, so they can be handheld devices. For example, they can be a COVID-19 test. We call them lateral flow assays. Or they can be even implantable chips that can be implanted subcutaneously, just right under your skin.
So you have developed, among the different projects that you're working on, one of them is you've developed a biosensing technology that can take the form of effectively a tattoo. Take me into this.
So this was a project that was developed in collaboration with the MIT Media Lab, and we worked with a number of designers and artists at that time. And the project emerged in early 2000s, and our vision for this project was to think about the next generation of wearable platforms. So as you know, the current wearable platforms can be in the form of a smartwatch, or it can be a temporary tattoo, so that's in the form of some type of patch system. But what we really wanted to do in this project is to design a seamlessly integrated platform that can be utilized for monitoring the concentrations of biomarkers in real time in a continuous manner. So we have developed a tattoo platform. So these are injectable materials, just like your traditional tattoos, but the difference is that these tattoos can change their color, or they can change their color intensity, or we call this a fluorescent intensity, in response to a wide range of target markers. So these target markers can be glucose, so that's for diabetes monitoring. They can be for proteins, hormones, or other types of important biomarkers that we really need to track in real time. So this allows us to do, for example, real-time or continuous measurements by the naked eye. So you can just look at the colors and you can determine whether you have high glucose, high sugar levels, or you have high stress levels. So these are usually based on colors. And the colors, for example, can change from blue to green to red. And based on those color changes, you can visually inspect the tattoo and make your own informed decision. And we can also utilize additional devices, for example, smartphones or a smartwatch, to capture an image of these tattoos. So once we capture the image using the smartphone camera, your smartphone will automatically analyze those images and provide a quantitative data. So exact values. For example, your glucose concentration may show up as 9.0.
That's pretty incredible. So effectively, I want to make sure I'm getting this right. Basically, you've developed a way to incorporate biosensor kinds of materials into, I'm going to use sort of like rough terms, effectively an ink that can be tattooed onto somebody's skin. So maybe you have something that appears at first glance to be just a really cool tattoo design. And then, but the biosensors that are embedded in it are, they're correlated with whatever the particular thing you're trying to track in your body is, whether it's glucose or stress or the different things you talked about. So you could have a tattoo of, say, for example, a butterfly on your forearm, and you're somebody who's concerned about your glucose levels. And rather than wearing the sort of a device that you wear on the outside of your arm, you've got this tattoo, and on any given moment, you could look at this and maybe the wings of the butterfly are green, or maybe it's red, or maybe it's somewhere in the middle. And the color variation would tell you what your glucose levels are and also alert you to when you're in range or out of range. Is that about right?
Yeah, that's exactly right. And that's the sort of the vision that we had behind this project. And we believe that this can be realized at least in the next 5 to 10 years and integrated into commonly used medical diagnostic technologies or platforms. So as you have just mentioned, the color changes are critical, and those color changes can be used to alert the patient, in this case, a patient with type 1 or type 2 diabetes. And the patient will be informed right away as the concentration of glucose spikes in their glucose,
Right.
in their blood glucose levels.
So here, I have so many questions. One of my curiosities is when you're developing something like this, so this is a new technology, and you're talking about something that is effectively injected into a person's skin. So I'm guessing it's not the easiest thing on an experimental basis to get permission to just do this on sort of like living people while you're doing it. How do you develop and test this? Is there some other substrate that you use to sort of like develop the idea before you actually get to a human being?
Yeah, regulatory hurdles is a big challenge in our field, and this is usually done in a number of steps. So the first step is to validate the technology in laboratory conditions, making sure that all the sensors are working correctly and they report on the concentrations of target biomarkers with a given sensitivity and selectivity values and correct detection range. So once this has been determined in laboratory conditions, the next stage is usually to carry out testing in blood samples. So we usually obtain blood samples from the patients, and we spike those blood samples with the target biomarker. So in this case, we can increase the concentration of glucose, or let's say we are sensing a protein using these patient samples. So once this process is complete, the next stage is usually to carry out live animal experiments. And recently, FDA has issued a guideline to reduce, in fact, some of those animal experiments. So we are moving towards more laboratory-based assays rather than utilizing the highest amount of animals that needs to be sacrificed in laboratory conditions. So, but today, such experiments are still required for having compliance with the FDA. So once that process is complete, we can determine the tattoos or these materials as you called inks, smart inks, are validated. We can move to the next stage in these are human trials. So we can carry out small human trials. So these range usually from 1 to 10 patients, and if these technologies are shown to be successful in human trials, early stage human trials, then we can move to a more complex, double-blinded or clinical trials. So these are multi-centered trials that includes lots of patients, around 100 to 1,000 patients, that provide a definitive measurements regarding the performance and sensitivity of the sensors.
I mean, when you're doing something like that, especially when you get to human trials, when you get to the sort of the gold standard, the double-blind, placebo-controlled trials, and for those listening, what that means is we've got a group that actually has the active treatment, and then another one which has a quote sham treatment, which for all intents and purposes they shouldn't be able to distinguish. They shouldn't know whether it's the real or the fake one. And the double-blind part is that the practitioners also don't know whether they're delivering. So that you're trying to eliminate bias from the whole process. In the context of a tattoo on somebody's skin that changes color, how do you do the fake part of it?
Yeah. So what you just described applies to traditional pharmaceutical drugs experiments and clinical trials. So in medical devices, we need to benchmark the technology to a current platform. So this may include, for example, finger prick blood measurements, or the blood measurements simply that can be sent to a centralized facility. And the current clinical standard at the moment is the wearable platforms. We call them electrochemical sensors, and they are usually marketed by Dexcom or Medtronic. So usually it will be benchmarked against a wearable platform like the Medtronic's system, or it can be a continual monitoring platform, such as the flash glucose monitoring systems from Abbott Libre system.
Got it. So it's a different sort of like design than what I was describing, which is more for a pharmaceutical-based intervention.
Correct. So it's a slightly different approach, but the aim is the same. So the idea is to determine whether your technology is safe and it's performing as it's advertised, basically.
Yeah. So we've referenced glucose monitoring a number of times. What are some of the other big things that this might be able to be used to help detect?
So beyond glucose monitoring, one of the areas that we are working at the moment is related to mental health monitoring. Currently, staggering statistics, there are 997 million people around the world who live with mental health disorders and challenges. So one of the projects that we are undertaking at the moment is to monitor the concentration of cortisol. So it's a stress biomarker that can be correlated with a number of mental health conditions. So this may include anxiety, depression, and other types of critical conditions. This technology that we are working at the moment aims to measure the concentration of cortisol in real time. At the same time, you're looking at some other biomarkers, including serotonin, adrenaline, and dopamine, which will be useful for applications in mental health monitoring. Such devices can also be utilized as I call it device, so because I consider it as a medical device. These are so-called inks. Are in the condition monitoring the conditions for fitness. So, for example, an athlete can utilize these devices to monitor the concentrations of electrolytes. This may be sodium, potassium, calcium, magnesium, and other important ions in their blood. So as they're exercising, they can determine their dehydration status in real time.
I mean, it's amazing because you're talking about health on the one side, we're talking about performance. And Are these the type of things also where I'm going to go back to that butterfly on my forearm, right? We've got the smart ink in there, and it's tagged a particular type of whatever it is that we're monitoring. Let's use the stress, the markers for stress. Is this a type of thing where you would potentially be able to see a color change on a tattoo on your arm before, because it's picking up, let's say, an increase in cortisol, before you're even consciously aware that you're actually becoming stressed, and it can alert you sooner than normal, so you could do something about it to try and downregulate your nervous system?
Exactly. So the whole idea here is to move from a single snapshot image. I'm talking about clinical diagnostics in hospital settings, to real-time or continuous monitoring platforms that we can alert patients in real time. So in the case of the cortisol sensor, the color will change, for example, from blue to green to orange to red. So these gradual changes in colors will be able to alert the patient in real time.
I mean, it's amazing because effectively what it sounds like you're also creating is it's a biofeedback mechanism. So if you see, you're heading into a meeting or you've got something stressful going on in the day, and you kind of look at this, you look at that tattoo in your arm, and it's starting to go from blue to the next to the next. And then let's say maybe you have a breathing technique that's your go-to for stress management or whatever, meditation. You could literally start to do we'll use breathing as an example, like engage in your slow breathing, and potentially visually see, from just the change in the color of the tattoo, visually see the markers for cortisol going down in your body. So it's this immediate feedback mechanism based on your behavior or intervention. Does that track?
Exactly. So what you're talking about here is the real-time feedback, visual feedback. This really falls within the realm of what we call the quantified self movement.
Yeah.
So I will briefly unpack what that is. So there's a growing number of individuals who are tracking their bodily biomarkers in real time. This may be glucose, their blood pressure, their heart rate. And there's a huge growing community around the world who's engaged in this in this community. So the idea here will be to provide quantifiable measurements to an individual in real time. So they will be able to engage with protective actions. So it may be a breathing, for example, exercise. It can be taking a medication, or just taking some time off and relaxing. So we will be able to, in the future, we'll be able to provide some of that actionable information to an individual until it's too late. Maybe in the mental health conditions, the patient may undergo a gradual, what we call a crisis. So it's an inclined level of crisis. So we will be able to intervene, or the patient will be able to self-diagnose themselves and monitor their condition in real time.
Yeah, I mean, it's fascinating because I feel like so many of us, we're not super tuned into our state of mind. We're not super tuned into our physiology. And we often don't realize something's going a little bit off the rails until we're deep enough into it that we're almost in crisis mode. So this presents an opportunity potentially to have something that can alert us a lot more quickly, so that we can come back into a better place of regulation long before anything becomes crisis mode.
Yeah, so this is basically the future of what you're talking about, the future of medicine. And if we don't measure it, we don't know what's happening. And so that's one of the challenges why a lot of people end up in emergency rooms and in clinics, especially not only mental health, but any other, health disorders or diseases, is that we don't know what's exactly happening. And not everyone also can track some of the symptoms and in a quantifiable manner. And we don't really know what's happening until someone ends up in an emergency room. So what we are trying to do here is to develop technologies that can be utilized for early detection of some of these disorders and diseases. But at the same time, we can build a bigger picture of the patient's health using continuous real-time monitoring platforms.
Yeah, it's so amazing. One of my questions, curiosity is floating around my mind now also is, I'm guessing that even once you have these smart inks well developed and validated, and you go through whatever the FDA process is to bring them to market, um, this is not going to be something that your typical tattoo artist is going to be doing. So how does this actually get implemented?
Yeah, so the way that we envision the implementation of this technology will be through a healthcare professional. So just like the current uh, continuous glucose monitoring technologies, you're going to have an applicator technology. So based on the pattern that you choose, the applicator will be able to apply that pattern to your skin with a push of a button, single push of a button. So you basically press the button and there will be a microneedle array platform that will inject the tattoo ink into your skin, and that will just be within just a couple of seconds.
That's amazing. And for anybody who's not familiar with the way that CGMs, continuous glucose monitors, work these days, generally you get a little delivery mechanism and you put it against your skin, you push a button, and it pushes a needle out of this little device and into your skin. But it's a microneedle, as you described. It's painless. You don't feel anything. I've done it many times myself. So you're talking about basically having something similar, but instead of one, there would be a pattern of microneedles that are injecting this into you, and it would be like pretty instantaneous also. So maybe a doctor's visit, you do the thing when you're there, and then you walk out and you've got your tattoo.
Yeah, that's exactly right. So the difference in this case, instead of inserting about half an inch small probe, a sensing probe, in just right under your skin, here we are talking about utilizing a microneedle array, which is much smaller, and that array will be able to determine the concentrations of these target biomarkers using color changes.
I know we're having this conversation sort of in the middle of the research phases. Do you have any sense for when something like this might actually be available for people?
So we are envisioning that this technology can be available in 5 to 10 years. And the reason for these time differences and why it's so long is that such technologies needs to go through very detailed clinical trials, and usually multi-centered and clinical trials that require patient recruitment, and also establishing that this technology is also performing better than the current existing technologies in the case of the electrochemical glucose monitoring technologies.
Yeah, I mean, that makes a lot of sense. And then in the context of all sorts of other things you might measure, there aren't easy technologies where somebody can just quickly, like put it on their arm or their belly or wherever it may be. They have to literally keep going into a practitioner or to a healthcare center to get new numbers. So like the possibility of this just providing continuous data for different types of markers where it's actually pretty burdensome to keep getting new numbers and new numbers. That sounds like it would be pretty game changing.
Yeah, so this is really the future of medical diagnostics we're talking about here. And currently we can do, for example, one biomarker, that's glucose. But in the future, this is going to be much more. So we will be able to monitor many other biomarkers that can be related to a health condition, or some of these biomarkers can also be utilized for preventative healthcare. So you will, for example, be able to know the concentrations of key biomarkers, let's say serotonin or dopamine, adrenaline, or cortisol, and you'll be able to make informed decisions before it's too late sometimes.
Anything that I didn't ask you that you feel like would be important to share?
Yeah, so one of the important points that I would like to cover is related to the stigma associated with having a tattoo or any type of medical diagnostic data stick to your arm, and anyone else around you is able to observe such information. Now, one way that we can get around such stigma issues is related to the design of this platform. So we can design these devices to operate in near infrared. So we can have invisible tattoo inks. Only your smartwatch or your smartphone will be able to see the signal coming from the tattoos, but you will be able to maintain the full privacy utilizing this type of platforms.
Oh, that's wild. So invisible to the naked eye, but you hold your cell phone up to it, and your cell phone will be able to see whatever the reading is.
Exactly. And another advantage of these platforms is for people who are using regular medication. So if you're utilizing a medication for your heart condition, or it may be for even for your mental health condition, you will be able to track the concentrations of key biomarkers, or actually the dosage of your medication, whether it's effective or not, in real time, utilizing this type of wearable platforms.
Yeah, it's just so incredible. I want to sit here and just wind the clock forward 5 or 10 years so we can just have this where, publicly available for millions of people, because it really sounds like it'll be a game changer.
Yeah, indeed. That's the vision that we have for this project.
Yeah, thank you so much. I really appreciate the conversation, you sharing the research you're working on. If you haven't yet subscribed to the show, it would mean the world to me if you took just 2 seconds to tap on that subscribe button. It helps us grow our Good Life Project community and continue creating the best possible show that we can for you. And it ensures you'll never miss an episode.